Look at modern global shipping, and you will notice vessels are ballooning in size. These megaships carry thousands of containers at once, but their sheer mass creates a severe problem for historic hubs like the Port of Genoa. Older ports were built for a completely different era of trade. They lack the deep water and wide turning radii required to maneuver massive modern freighters safely. If a port cannot accommodate the physical geometry of a megaship, shipping routes simply bypass it entirely. This map of the Genoa harbor illustrates the proposed solution. To save the port's shipping capacity, engineers are drawing up a massive new outer breakwater. You can see the new footprint taking shape here, a 300-meter-wide access channel leading into an 800-meter-wide turning basin, giving giant vessels the open space they need to rotate and dock. But executing this plan requires constructing a continuous sea barrier over 6 kilometers long. The core of this wall relies on what engineers call caissons. Think of a caisson as a hollow concrete building, 10 stories tall, that is constructed on land, towed out to sea, and deliberately sunk to form a structural foundation. You cannot pour standard construction materials in the middle of deep, violent ocean currents. The corrosive salt water alone would eat right through it. To build a wall of this scale, engineers had to invent an entirely decentralized manufacturing pipeline. The first node of this pipeline sits safely on dry land. Here at the Vado Ligure construction site, the raw materials are assembled in a highly controlled, stable environment. The Mediterranean Sea attacks submerged structures chemically as well as physically. While waves batter the surface, chlorides and sulfates in the salt water seep deep into standard concrete mixes, steadily degrading their structural integrity over time. Heidelberg Materials engineers a highly specialized concrete mix to solve that problem. Instead of a static product, the concrete is treated as a dynamic chemical formula. If local temperature drops or aggregate moisture shifts, material ratios are actively recalibrated to ensure the final product resists marine corrosion. Once that specialized mix is perfected, it is poured continuously to cast the thick, heavy walls of those massive hollow caissons. Perfecting a high-durability material in a lab is a known science. The true engineering hurdle is migrating these colossal blocks out of the safety of the harbor and into the chaos of the open ocean. Completed, a single concrete caisson spans 67 meters long and rises 33 meters high. Entire fleets of tugboats hook up to these floating monoliths, towing them at a crawl across the Mediterranean toward the build site. Arriving at the exact GPS coordinates, crews begin the meticulous process of flooding to hollow chambers. The massive structure descends steadily through the water column and settles onto a prepared gravel bed on the seafloor. There is zero margin for error here. A sudden spike in wind speed or a shift in the wave frequency can violently displace the caisson on its way down. Placing these blocks forms the underwater foundation, but sealing them off with a heavy concrete lid demands bringing industrial production directly onto the unpredictable waves. To complete the top of the wall, the team deployed a custom dual concrete production plant mounted entirely on a floating barge, anchored nearly a kilometer off the coast. It operates on a relentless cycle. At night, the barge docks to load raw materials. At dawn, it deploys back out to manufacture concrete on site. A side profile reveals the operation. A long boom arm pumps material straight down into the sunken caissons to cast protective lids. Operators monitor chemical consistency in real time as the entire floating factory pitches and rolls with the ocean waves. Running heavy, high-pressure industrial machinery on a platform that drops and lifts by the second requires strict safety protocols. Every human movement and mechanical calibration must anticipate the motion of the sea. By stabilizing complex mechanical processes atop a moving surface, this floating factory turns a hostile, unstable environment into a precisely controlled industrial workspace. Pull back and you can see the entire continuous supply chain operating in tandem. Raw materials engineered on land in Vado Ligure, colossal blocks towed out to sea, and a floating plant mixing the final pieces a kilometer offshore. By successfully implementing this pipeline, the Port of Genoa guarantees its future. The expanded, protected waters will safely host the next generation of massive freighters, maintaining the city's status as a high-capacity international shipping hub. The implications of this project stretch far beyond a single city in Italy. The complex logistics developed here prove that deep water infrastructure can be dynamically manufactured on the very waves it is designed to hold back. The builders engineered an active industrial process that adapts to the ocean's forces. By integrating their manufacturing directly into the marine environment, they pushed the limits of coastal engineering far